right, welcome back. Let's look at calculation based on chemical equation. There are some calculation we can make based on chemical equation. Number one thing, first is first. Note this, please. Before you do any calculation under chemical equation, first thing to note, please. Note this, please. Note. First is first. Note, please. Note. All equation must be properly balanced. All equation must be properly balanced before any calculation is carried out. Your first is first. All equation must be properly balanced before any calculation is carried out. Now, what are these calculations we can do based on chemical equation? Number one, please. Number of mole of reactant and product. Number one is called number of mole of reactants and product. The first calculation we can make under chemical equation is called number of mole of reactants and product. All right. Now, I won't give you much notes under this. I'll just take an example and explain this further. So, example one, please, on this, please. So, for example, when I'm saying that when it comes to calculation based on chemical equation, there are basically several calculations under this place. The first one is called the number of mole of reactant and product. You want to know how many mole are in the reactant, or perhaps how many mole are in the product. It depends on the question, right? So let's look at how this works. Example. So I'll just give one example for each of them, each of the calculations, and then we'll proceed from there. Example, please. Example. Nitrogen combined with hydrogen to form ammonia. How many moles of hydrogen are required to react with 300 mole of nitrogen? Nitrogen combines with hydrogen to form ammonia. How many moles of hydrogen is required to react with 300 mole of nitrogen? This is the equation, please. On the board, equation on the board. N2 plus H2 to give you NH3. Now listen, please, and listen. This is the equation attached to it, the chemical equation attached to it, please. Now, the equation says nitrogen combined with hydrogen, Abi. Nitrogen combined with hydrogen to form ammonia. How many mole of hydrogen are required to react with what? 300 mole of what? Nitrogen. Your very first task here to do is to check, is this equation balanced? Check, is it balanced? Of course, we said when it comes to calculation under chemical equation, your very first task there is to check if the equation is what? Is balanced. This man, is it balanced? Yes or no? Let's check, please. N2, N is 1 here. H is 2 here. H is 3 here. So it's not balanced, please. So if I come here and add, if I add 2 here, N2, 1 times 2 gives you N2. H2, this is H here. H is 6 here. So times 3 is 6. I also come and put 3 here. 2 times 2 is 6. So this is because what now? Now a balanced chemical equation. Your first task under any question, under calculation based on chemical equation, your first task is what? Balance the equation. Your second task is to get molar ratio. Please, any question under this topic here, your very first task, balance equation. Next task, get what there? Molar ratio. Get molar ratio. So what's molar ratio? In a layman, molar ratio is simply the coefficient of each of the reactants, of each of the term in the reactant and product side, right? The coefficient in each of the reactant and product side is called the molar ratio. Now, here's the idea when it comes to molar ratio. We said the coefficient of the term. So the number in front of this one here, number in front of this one in this one here. So molar ratio for this reaction becomes 1:3:2. This is 2 here. This is 3 here. There's a 1 here. This is how to get the molar ratio. First is first, balance equation. Next task, get what? Molar ratio. When you are done, please. Now, listen and listen. Listen and listen. When it comes to calculation based on chemical equation, no matter how long the equation is, no matter how long the equation is, they'll focus your mind on two things. In our question, it was nitrogen and what the hydrogen. That's all. Check. It says, example says, nitrogen combines with what? Hydrogen to form ammonia. How many mole of hydrogen is required to react with what? 300 mole of what? Nitrogen. In this case, it was what? Hydrogen and what the nitrogen. No matter how long the equation will be, they will narrow your focus on two elements or two compounds, whatever thing there. Focus on what? On two things there. I said, for every calculation that involves an equation at your level, no matter how lengthy or long the reaction and the product may be, they will always give you what there. Focus your mind on what? On two stuff there. In this our question here, it was what there? Nitrogen and what? And hydrogen, because it says how many moles of hydrogen is required to react with what? 300 moles of what? Nitrogen. So it was what? Hydrogen and what there? Nitrogen. That's the concept. So I focus on what? On these two. Right? So that's the first thing. You should know that they will always focus your mind on two things. I will put now. Now, at this junction here, please note. At this junction here, note. Note. From the balanced chemical equation, above, it requires 3 mole, perhaps it requires 1 mole of nitrogen. I said from the equation balance above, this one here, it requires 1 mole of nitrogen to react with 3 moles of hydrogen. You know, in the question they said they said how many mole of hydrogen is required to react with 300 mole of what? Nitrogen, Abi. So what we're looking for is what? Hydrogen. How many mole of hydrogen is required? So we don't know the amount of hydrogen that is required to react with 300 mole of nitrogen. So let's call it X. So I'm saying that from the balanced chemical equation above, it requires 1 mole of nitrogen to react with what? 300 mole of what? Hydrogen. Hence, copy this down. Oh. Hence, let the number of mole, hence, let the number of mole that will react with 300 mole of nitrogen be X. Let the number of mole of hydrogen that will react with 300 mole of nitrogen be X. I said, let the number of mole of hydrogen that will react with 300 mole of nitrogen be X. So hence, it means that I'll be having this place. Look up, please. I'll be having this place. Our focus was on two things, Abi. This and this. So that I have N2 and what there? Sorry, N2 and what? And H2. Please observe, I didn't write 3 here. This was balanced. I didn't write 3. It was the N2, H2. For N2, it is required 1 mole to react with what? 3 mole of hydrogen. Now we said the number of mole of hydrogen should be X. That will react with what? 300 mole of what? Nitrogen. All right. So this one here gives you this. So in this case here, our what? Multiply 1 times S gives you 1 times X equals 3 times 300 gives you 3 times 3 100. This one gives you x equals 900. 900 what? 900 mole. So it means that it requires 900 mole of hydrogen to react with what? 300 mole of what? Nitrogen. That's like the idea behind this stuff here. So it means that it means therefore 900 mole of hydrogen H2 is required to react with 300 mole of nitrogen. That's N2. So in summary, I said when they give you equation, balance it. When you're done balancing, get what the molar ratio of each of them. When you're not getting molar ratio, they'll focus your mind on two things. Check your question. In this case here, it was how many moles of hydrogen is required to what is required to combine with 300 mole of what? Nitrogen. So our focus was what? Hydrogen, nitrogen. I came out here, I wrote nitrogen, hydrogen. In the question, it was hydrogen first before nitrogen, but follow the pattern of what? The given equation. So nitrogen first, N2, then I didn't write 3, it was H2. I didn't put 3, H2. I have H2 here. So for molar ratio, it was 1 and 3. So 1 and 3, 1 and 3. Next up, get the moles. They said nitrogen has 300 mole. So hydrogen is what we're looking for. Because I said how many mole of hydrogen? So we said let it be X. So let it be X. That we ask about 300 mole of what? Nitrogen. Then you what? Multiply from here, and then you have your 900 mole. This is the first calculation you can possibly make under chemical equation. And the first one is called the number of mole of reactant and product. The second calculation we can make under this is called the second calculation is called mass of reactants and products in a given chemical equation. Number 2, second calculation we can make under this place. Number 2, second calculation we can make under chemical equation. Number 2 there is called the mass of reactants and product in a given chemical equation. So this is the second calculation we can make based on chemical equation. The first one was what? Number of mole of reactant product. Second one is now called mass of reactant and product of a given chemical equation. Let's take an example under this one here and still explain how to solve problem under this second calculation. Example here, please. It says, what mass of oxygen is required to react completely with 1.20 mole of methane? It says, what mass of oxygen is required to react completely with what there? With 1.20 mole of methane. In this case, focus was what? I'm getting oxygen and methane here. That's all. Oxygen, methane. That's our focus. Don't stress yourself. They give us the equation as CH4 plus O2 to give you CO2 plus H2O. This man is too long. Our focus was what? On what? Methane and what? Oxygen. That's all. Now, it says, listen, Okay, before we start solving, we said your first task, balance the equation. Is it balanced? Carbon is 1, yeah? Carbon is 1, no problem. Hydrogen is 4. Hydrogen is 2, yeah? So I come here and put 2, yeah? That makes 4. Oxygen is 2, yeah? Oxygen is what? Is 2, yeah? Sorry? Oxygen is 2, yeah? Oxygen is 2 is 1, that's 3. Sorry? Okay, 1 here, 1 times 2 is 2. So 2 with 2, that's 4, yeah? Is 2 here. I have to put 2 here. 2 times 2 gives you 4. Now, this is now balanced, right? Yeah, this is balanced now. We said after balancing the equation, what's next there? Get molar ratio. Get what there? Molar ratio. And it's easy as the value in front. Here was 1 ratio 2 ratio 1 ratio 2. This is the molar ratio we're working on. Now, here's the tax and the idea. You know that it requires, not our focus was on methane and what? Oxygen. So focus was on what? Methane, CH4, and what there? And oxygen, O2. The molar ratio was 1 here and what? And 2 here. Now, the task is, what do I ask to find? They said, now, before you write this one here, please, if you are here, note. Let me just give you saying, in case you want to read. If you are here, note. Each from the balance equation above, if you are here, please note. From the balance equation above, it requires 1 mole of methane to react with 2 moles of oxygen. From the balance equation above, this one here, it requires 1 mole of methane to react with 2 moles of oxygen. Now, before I finish up the stuff here, now check the question very well, please. Check the question very well. They said, what mass of oxygen? In this case, we are looking for mass of oxygen, right? But before you get mass of oxygen, we need to get what? Mole of oxygen first, right? They said, what mass of oxygen is required to react completely with what? 1.2 mole of what? Methane. So methane has a mole. So oxygen does not have a mole. Oxygen, we have to find the mass of oxygen. Before we get the mass of oxygen, we have to get the mole of oxygen. So from here, I said, from the balance equation above, it requires 1 mole of methane to react with 2 mole of oxygen. Hence, let the number of mole of oxygen that will react with 1.20 mole of methane be X. Let the number of mole of oxygen that will react with 1.20 mole of methane be X. So it means that from having methane and oxygen, 1, 2, 1, 2, no problem. For methane there, it was what? 1.20 mole. Oxygen is what? Let's call it X because we don't know the mole first. We are asked to find mass, not mole. But we can't find mass without mole because we know that mole is what? Mass over molar mass. We are asked to find mass, then you need mole. So mole of oxygen. No, I make that part X. So 1 times X gives you 1 times X equals 2 times this gives you 2 times 1.20. This gives you S is equal to, multiply this by this, that gives you 2.4 mole. So it means that it requires 2.4 mole of oxygen to react what? 1.2 mole of what? Of methane. But we're not asked to find mole of oxygen. We are asked to find what? The mass of oxygen. For me, you now recall that mole is what? Mass over molar mass. All right. Now, mole of oxygen is what? 2.4, right? So I know the mole of this, so express everything in terms of oxygen. That gives you mole of oxygen equals mass of oxygen over what the molar mass of oxygen. Molar mass of oxygen. So let's get this done, please. So we want to get mass of oxygen. All right. So make this one subject. So over 1 times this gives you mass of oxygen. Mass of oxygen equals what there? Mole of oxygen times molar mass of oxygen. That gives you mole of oxygen times molar mass of what? Of oxygen. Now, we know the mole of oxygen as what there? 2.4. But we don't know molar mass of oxygen, O2. Now, let's get molar mass. So, molar mass of oxygen is equal to, the compound there is O2. Now, oxygen is atomic power there? 16, right? So, the mass number is 16, then times 2. That gives you what there? 32 gram per mole. Gram per mole. This is the molar mass of oxygen. So oxygen is mass number is 16 times this 2, that gives 32. So the molar mass of oxygen is 32. From here, I cannot get mass of oxygen. So mass of oxygen equals molar mass of oxygen is of course 2.4 times mole of oxygen is 2.4. Molar mass of oxygen gives you 32. From here, the mass of oxygen that gives you about 6.8 gram. This is the what? The mass of oxygen we are asked to calculate. Now, our first calculation was just mole. After looking for mole, we stopped. Here, we look for mole, we now look for the mass of that element. That's how we work with this second part here. All right. Let me give an assignment to try, and then leave your answer to the comment section of this in the video. It says, assignment please. What mass of oxygen is required to react completely with 24.0 gram of methane? Please, the equation will be okay. Let me write the equation outside, please. That question I gave you now. This is the equation. This is the equation attached to it, please. CH4 plus O2 to give you CO2 plus 2H2O. All right, this is the formula attached to that question I gave you. It says, what mass of oxygen is required to react completely with 24 gram of methane? Usually, that methane, 24 gram, was supposed to be given in mole, right? So your task is to convert that 24 gram to mole first. Okay. Let's do it together. Let's do it together, please. Let's do it together. Let's do it, please. Let's do it. Let's do it, please. Let's work on this, please. All right. The formula goes below. They give us CH4 plus 2O2 to give you CO2 plus 2H2O. Observe that in this case, it was what we used in our example 1 under mass of reaction and product. So it was the same equation, but they gave us this, they said what mass of oxygen is required. We're still to find mass of oxygen. Okay, is required to react completely with what? 24 gram of methane. So we're focusing on methane and oxygen. So methane and oxygen, no problem. Get molar ratio first. That gives you 1:2:1:2. After getting molar ratio, we said the next task there is that observe. They said what mass of oxygen is required to react with what? Completely with what? 24 gram of methane. That's 24 gram of methane. They are meant to give us methane in gram, in mole, not in gram, right? So they said completely with 24 gram of methane. So it was now the idea is this, please. The idea is this, please. We now said from here now, we know that we usually say note that 1 mole of methane is required to react with 2 mole of what? Oxygen, right? So in this case now, we know that it's meant to be something like this. Since we're having methane, CH4 and O2, we said here is 1, here is 2. What is meant to be here is mole, right? That we did before. We'll put one will be X, the other one will be something in mole. But here, in this case, they gave us the mass of methane as 24. I can't put mass here. It's meant to be mole that will be here. So I have to convert this mass here to mole. Normally, we don't know what the mole of oxygen is, so I call it X. So let's find the mole of methane. So let's find the mole of methane first. So let's converting 24.0 gram of methane H4 to mole, right? So I can use it there. That gives you, we know that mole is what? Mass over molar mass. Molar mass, right? So let's get molar mass of, so to get mole of methane, we need mass of methane. So mass of methane is this. So we still need what? Molar mass of methane. So the molar mass of methane, CH4, will be C, atom number 12, plus hydrogen is just 1, then times 4, right? This 4 here. That gives you 12 plus 4. That gives you 16 gram per mole. So the molar mass of methane, CH4, is 16 gram per mole. All right, 16 gram per mole. From here, let's now put mass and molar mass to get mole of methane. So the mole of methane, CH4, will be equal to what there? Mass of methane, that's 24. 24.0 all over molar mass of methane is 16. So the mole of methane, CH4, will be equal to, if I divide this 2 here, that gives you 1.5 mole, right? Mole of methane. So we will now say let the number of mole of oxygen that will react with 1.5 mole of methane be X. So at this point now, you now say let the number of, now you know that here will be X now, oxygen will be X. Now mole now, the gram is now in mole. You can now put it here and then multiply to get X, which is the mole of oxygen. Now at this point, if you are here, please note. Here, note. Let the number of mole of oxygen, let the number of mole of oxygen that will react with 1.5 mole of methane be X. Hence, I'll be having this, please. I'll have CH4, then oxygen. Here was 1 and 2. Oxygen is, let's see, the X. The mole here now is now 1.5, right? The mole there is now 1.5. From this place here, I'll multiply, cross multiply. 1 times S gives you X equals 2 times this gives you 3.0 mole. So it requires 3.0 mole of oxygen to react with what? 1.5 mole of what? Methane, from this concept here, right? So I haven't gotten the mole of oxygen. The question says, what is the mass of oxygen? Now the question says. It says, what is the mass of oxygen? So since I've gotten mole of oxygen, I can now get what? Mass of oxygen. Now we know that, recall, recall that mole is what? Mass over molar mass. But I'm looking for oxygen, mass of oxygen. So mass of what? Oxygen, O2. Molar mass of what? Oxygen, O2. Mole of what? Oxygen, O2. Just put everything in terms of O2, O2, O2. Because they're dealing with oxygen. Now, mass of oxygen, that is mass of oxygen, O2, will be equal to the product of what? Mole of oxygen and what? Molar mass of oxygen. So mole of oxygen times molar mass of oxygen. Molar mass of, that's your own in full, please. Molar mass of oxygen. We already calculated molar mass. So now from here, mass of oxygen, the mass of oxygen will be equal to what? Molar mass of oxygen is of course 3.0 times mole of oxygen. We did it earlier before now. See it here. Okay. I've covered the board. Check your book. We did mole of oxygen, molar mass of oxygen. That was 64 because it's 16 times 2. Right? 20. Let me check. We already did the calculation for molar mass of oxygen before. Just check it there. 32 per se. 32. All right. So the mass of oxygen here will now be equal to what? Multiply this 2, that gives you 96 gram of oxygen is required to react with what? 24 gram of methane. This is how you solve this particular question. So try this at home, please. Calculate the mass of carbon 4 oxide in germs that can be produced by burning 6.0 mole of methane with excess oxygen. The formula is still okay. Perhaps get the formula yourself and then solve it and leave your answer in the comment section. So give me the mass of carbon 4 oxide. I have to calculate the mass of carbon 4 oxide, right? That can be produced during the burning of 6 mole of methane. So carbon 4 oxide will be methane in this case. See, you see the same formula. See the same formula you're using. But carbon 4 oxide, this one here, with methane. So you're combining this with this. In this case, it's not this and this again. It's now this with this. So that becomes 1 and 1. So instead of using 1 and 2, becomes methane and what there? And CO2. That one. From there, you can get that stuff done and dusted. This is how it is. This is how it works, please. All right. See you guys in our next class.
Before we continue with this lesson, I'm excited to announce that I just launched my official website, a complete learning platform designed to help you study smarter, learn faster, and access high-quality educational resources anytime you need them. On the website, you'll find several well-structured courses created to guide you step by step through the most important topics. First, we have Organic Chemistry for Beginners, a simple, beginner-friendly course that breaks down organic chemistry into easy explanations anyone can understand. Next, there are WAC and JAM classes, specially designed to help you pass your exams with confidence using clear lessons, solve questions, and exam strategies. We also have the Physics tutorial for Year 1 students, covering foundational concepts you must master in your first year of higher education. And for anyone who wants to grow online, there is a complete course on how to start, grow, and earn on YouTube using only your smartphone. This course gives you everything you need to begin your YouTube journey without expensive equipment. There is also a book section on the website where you can get all my educational books, including the shortcut to academic success. My website is now your one-stop platform for science tutorials, exam preparation, YouTube training, and learning resources that can transform your academic and digital journey. To explore all the courses and get your copy of the books, simply click the website link in the video description. Hold on, before you continue this lesson, I need to tell you something important. If you've been struggling with studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of The Shortcut to Academic Success today. Your future self will thank you. Before we continue, let me quickly share something that can change your entire online journey. I just launched a complete YouTube mastery course, a step-by-step training designed to help beginners start and grow a successful YouTube channel using only their smartphone. In this course, I break everything down in simple, practical lessons. No expensive camera, no studio, no complicated equipment, just your phone and the right knowledge. You will learn how to create quality videos, design engaging thumbnails, write perfect titles, choose the right niche, understand the YouTube algorithm, and grow your channel from zero, even if you've never created a video before. If you want to become an online teacher like me, this course will guide you on how to teach online, record lessons, explain concepts clearly, and attract the right audience. And if you want to create content in any other field, lifestyle, motivation, entertainment, business, this course will still show you the exact steps to succeed. All the lessons are pre-recorded, well-organized, and easy to follow. You can watch them at your own pace, anytime, anywhere. So, if you've been dreaming of starting a YouTube channel but didn't know how to begin, this is your opportunity. This course will take you from beginner to confident creator. The link to get the YouTube Mastery course is right there in the video description. Click it and start your YouTube journey today. Before we continue this lesson, I want to share something that will make your learning experience even better. I now have exclusive channel memberships designed to help you learn faster, get direct support, and access premium content you won't find in my regular videos. The first level is the Support membership. If you enjoy my lessons and want to support the channel while getting special perks, this is for you. It's a simple way to show appreciation and help me continue creating high-quality educational content. The second level is the WAC and JAM classes membership. If you're preparing for WAC or JAM, this membership gives you structured lessons, practice questions, exam strategies, and step-by-step guidance to boost your performance. The third level is the 100-level students membership. This is perfect for secondary school students who want organized, easy-to-understand lessons in physics, chemistry, mathematics, and other subjects. And finally, we have the YouTube Mastery membership. If you want to learn how to grow on YouTube, how to create content, edit videos, design thumbnails, and monetize your channel, this membership will guide you from beginner to creator. Whatever stage you are in, there's a membership designed to help you learn smarter, improve faster, and stay ahead. To join, simply click the membership link in the video description. Choose the level that matches your goals and start enjoying all the exclusive benefits.